Sir, mute ka, sir.
Good evening. Let us start now
Sige,
with our
sir.
discussion about Ohm's law. Okay, let me share my screen. Now, in this topic, we will be discussing about voltage, current, resistance, and its relationship to each other. I'm sure you're familiar with this one already because during your high school science, probably you have tackled this one. But let us make it a little bit more exciting than what you had experienced during your high school. Okay? So first na to, we are going to discuss about voltage. Also called, it is sometimes called the electric potential difference, the electric field pressure, or electric tension. It is a difference in the electric potential between 2 points in the electric field. Okay? So that atong sabtan, okay, when we talk about potential difference, mura na siya potential difference o kuhan. Diferensya ba? Yung potential. To make it to make it much simpler to understand, mura na siya yun ani. Okay. The schematic diagram of a battery or pictorial diagram of a battery. Di ba, we all know, sa atong battery, composed na siya of duha ka buok niya, duha ka klase nga substances. Ang usa diri sa ibabaw, ang usa diri sa budlot, mo ni siya imong mga positive charges. Mo ni siya katong mga atoms nga nakuhaan og electron. Di ba? Ato magi-discuss last time nga kung nakay mga molecules or mga atoms nga na naka-lose sila og electron, nakuhaan sila og negative charge, hitabo mahimo silang positive charge. Ya kaning atong nasa tong lupyak sa tong battery, mao ni siya katong naay daghang mga free electrons. Okay? The same sa dire. Dinhi kaning imong taas, mao ni siya imong positive, kating imong mubo, mao ni imong negative. Of course, kani siya imong mga positive dire, gusto na siya mobalhin padung sa imong negative. They have the potential to move. Kaning mga free electrons dire na siya potential nga mosuod padung didto. But of course, dili sila kaagi tungod kay gibutangan dire gialihan nato dire og insulator. No? Dili kaagi. So kung butangan nimo nag-wire nga gayon ana, wire nga gayon ani, ang mahitabo ana niya diha ka kutob, di nimo sangkuon sila. Kani siya tanan managan as sila nimo padung dire. Kani siyang ihang mga positive managan padung dito. But they cannot combine. Gusto sila combine but di sila combine. Now karon kung ako ni siyang butangan diri o voltmeter, this is the schematic symbol for a voltmeter. Akong ibutang diri akong voltmeter, i-connect diha, yang kaning pikas, i-connect ko diri. What will happen is that mo-deflect ni siya, mo-lihok or mo-register siya voltahe. Why? Because there is an electric potential. Naay potential. Unsa may pasabot og potential? Naay potential nga naay electric current, but because wala siya agianan, wala siya conducting path, ang may tabo, nara siya voltahe, but there is zero current. Okay? In statics, it is defined as the work needed per unit charge to move a test charge between 2 points. Okay? What is meant by statics is ang imuhang kurente is wala pa ni flow. there is a difference between between the charges between the two objects. Okay. Kung sa may example aning statics, mo sa gitawag na itong electrostatics discharge. Okay. Example na niya is kanang lightning, which we have discussed last time. Nga unsay may tabo dihay, inigabot dito sa kalawakan, magbuwag ang positive ug negative, so that they wanted to combine with each other, but because of the insulator between the two, they cannot readily do so until such time nga mo accumulate magkadako ang ilahang potential difference. Another example na niya class is kung naka sa inyong balay, nagtiniil ka, nya namoy carpet sa inyong balay or namoy trapo or namoy fur, sa manang fur, ang mga balhibo sa iring. Maghikig kag hikap ang balhibo sa iring, what will happen is that ang imong lawas will gain electron. And sometimes naghikap ni mosdor na makurintihan kag kalit. Mo na gitawag na to og electrostatic discharge. Another example is kuan. Muhikap ka og rubber or nakay, say for example, I don't know kung naka-experiment mo ni pag high school, no, for sure wala kay online man ta. But kung magisi-gisi ka gagmay nga papel, say for example kaning papila, imo ning gisi-gision gagmay kaayo pieces of paper, then magkuha ka og ballpen, imo siyang ibagnod sa imuhang eraser or anything basta rubber. Ang mahitabo sa imong ballpen is that nakuhaan og mga free electrons, mga valence electron. So kay nakuhaan man siya valence electron, what will happen is that ang imong ballpen mahimo siyang positively charged. So that kung ipaduol nimo siya sa papel nga imong gipunit-punit o gagmay, ang mahitabo ang mga papel mupilit. Okay? So na siya static charge. Na siya unbalance ang iyang charge. Na siya charge. It could either be positive kung gibagnos nimo sa rubber. It could be negative kung imo siyang gibagnos sa fur. Now, electric potential difference between 2 points can be caused by electric charge, by electric current, through a magnetic field, by varying the magnetic field, or some combination of these three. Okay? Okay, yung sa ng magnetic field. Gauna nag-experiment si Michael Faraday. Si Michael Faraday niingon nga iyang na-observe nga nasa wire, example lang, wire ni, then nasa magnet. Utang lang ang magnet ni. Then iyang gipaduol ang magnet sa wire so that nga ang magnet wala pun mosangko sa wire. Then iyang gibuhat is that iyang gilihok ang magnet. Now pag lihok niya sa magnet, what happens is that iyang na-observe na naka-generate siya og small amount of current. Okay? And that current, when we say current, that is a movement of charged particle. And that movement of charged particle is caused by the magnetic field that is also caused by the magnet. Okay? So mo na siya hinungdan, diha gasugod ang atong pagka-discover sa kuryente. In fact, mao na karon ang gipanggamit kung kabantay mo na amoy mga dynamo sa inyong balay. What will happen is that kung ang dynamo butangan nimo kuryente, it will turn. Nganong mo turn man na siya ang dynamo? Naman na siya magnet. Gatuyok ana niya, then ay isod nimo dihang armature. Now, yang imong armature nga gisod is na siya coil of wire. Now, inigdagan sa kuryente, ang may tabo, mutuyok po ang imong armature. Mo na nga mutuyok ang dynamo. By the way, kailan mo dynamo?
Oh, sir.
Kaila sir.
So dynamo ka ng motor, electric motor.
Tapos sa electric pan.
O na sa electric pan. Complicated lang na siya sa electric pan because it is designed for alternating current. Dili man siya designed for direct current. But basically, mo na siya. Di ba? Kabantay mo, padagana ni mo kuryente ang electric fan, unsay mahitabo is that mutuyok iyang blade. Now, ato na siyang balihon. Atong balihon ang electric fan, theoretically. Imong tuyokon ang fan blade and ang electric fan, it will produce small amount of electric current. Kami naka-experiment kami sa una na nagtudlo ko og physics, then na ay project ng mga bata gipahimo na kog sort of like a mini generator using the motor of an electric fan. Kanang motor kanang sa ceiling fan gani kanang baligya sa merkado. Okay. So moro tayo lang among gibuhat imbis nga palabad siya among gitauran o gimapitlan na mo mga kutsara so that ipatungod na mo ang mga kutsara sa gripo sa may mitabo mutuyok ang blade. Ituyok sa blade, it will generate a small amount of electric current nga makapa-turn on sa atong LED. Okay, so mora na siya, bali-bali naman na. A voltmeter can be used to measure the voltage between 2 points in a system. Often, a common reference potential such as the ground of the system is used as one of the points. Okay? So dinhi, for example, dinhi, na common reference point. Say for example, gingon ani. Ako ni siyang gitaod sa usa ka bombilya. Tinitaod na ko usa ka bombilya diha. Siyempre, nani current dire nga gadagan or nani mga positive charges nga gadagan. Dili nasa mga negative charges nga dagan nga moabot silang duha. If there is a movement of charges, automatically there is the existence of electric current. Siga ni mong bombilya. Now, gusto ni mong measureon kung pilay voltahe ang bombilya, mutaod lang ka diha o voltmeter. Diha, bisag asa diha dapita, basta kay diha. Dapita sa input nga side sa imong battery, dire sa pika sa mo. Across, the voltage across the electric valve. Makuha ni mo ang voltahe ani niya. Okay? Kani mo na example. The picture on the right shows how a voltmeter is to be connected to effectively measure the voltage of the circuit. It should be connected in parallel with that of the source or of the load or on the device where you want to measure the voltage. So in this case here, we have here a battery, not an electrical load. It could either be a resistor, it could be a suga, it could be a computer. Di natin voltmeter dire, ato gyud na siyang iparallel. Dili pwede nga kani siya anhi po dire i-measure. Wa gyud kay potential difference. Nga naman, puro man positive ang nadire. Ang nadire is negative. And we all know that voltage is the electric potential or the difference between the two terminals nga imong i-measure. So aron na diferensya, imo gyud siyang i-measure across. Now, why are we going to measure it in parallel with that of the source? Because it is a property of the voltage nga kung whatever is the voltage sa parallel niya, automatically equal. Anyway, we can discuss that one later. Electric current. Electric current is a movement of charge from one point of the electric field to the other. Now, in this case here, na movement of charge. Kung imong putlon, like yung ani putol, wag yung movement of charge na. Nara siya electric potential or nara siya voltahe, but there is no electric current. Gano man, putol man. But the moment nga imong sumpayon na silang duha, what will happen is that kanis latanan managan, kaning mga charges dili managan. Now, we all know nga kaning mga free electron nga nanagan, electron ko na siya. And we all know that electron is a charge particle. And if there is a movement of charge, automatically there is always electric current. Okay? This is the main reason class nga nung yun ani ha. Kung kabantay mo na poste sa inyong gawas si Beko. Okay? So ibutan ta poste na siya no. Yun ana, di ba naman ay wire diha. Yun ana man ang wire. Yan naman ay kasunod pud nga wire. Yun ana. No? This is the main reason class nga kung nailanggam diha mutog pa, di gyud na makurintihan. Ano man? Ikaw mupatong po ka dito, di po ka makurintihan ana. Usa lang ka wire ang imuhang tumban. Why? Wa man di man moagi ang kuryente kay ang kuryente anhir man moagi dire. Dili man moagi sila nimo. Okay? But kung mutunog ka sa wire, mag-ana ka dire, mugunit ka di, mutunog ka dire sa wire sa ubos, then mo hikap imong kamot sa babaw. Please, ikmusod, palihog, i-mute, kaya ron dili makadisturbo sa uban. Okay, maging-anak kag porma, automatically, makurintihan jud ana because there is already a conducting path. Ang current moagi sa imong mga kamot, moagi sa imong heart, balik dire. So unsa ni tabo? Ni kirig ka diha. Okay? Okay, it is one of the requirement in order for electric charge or electric current in order to have an electric current, there must be a conducting path na ay agianan sa mga charges. It is a flow of electric charge or rate of flow of electric force in a conductor that transport energy from one place to another. When two objects with different charges touch and redistribute their charges, an electric current flow from one object to the other until the charge is distributed. If two objects are connected by a material that lets charge flow easily, such as copper wire, then an electric current flows from one object to the other through the wire. Electric current flows because atoms and molecules contains two types of electric charge, the positive and the negative. And these opposite charges attract each other. Di ba? Sa ako nagingon yung sample, no? Na kay positive, na kay negative, syempre, they will attract with each other. Always yun na siya. Parihara ko na, og na kay North Pole sa imong magnet, o South Pole sa imong magnet, imo nang sikiton sila, they will really attract with each other. But, kung imong ibutang is duha ka North Pole, mabuang na lang kag dinuot, ana, they will not be attracted to each other. They will repel each other because pareha sila o polarity. Now, if there is a difference in the overall charge of atoms between 2 points, for example, between two ends of a wire, the negatively charged electrons will flow towards the positively charged end of the wire, creating electric current. Now, electric current flows when the following are present. Mao gani hinungdan nga naay electric current. There must be a source of voltage. Of course, klaro kayo, no? Kaya kung wala kay battery, awag yun ay kuryente ang imuhang cellphone. Wala ni mo gipaslak or brown out gani, di gyud na moandar imong computer unless imong computer na ay battery. No? Nga naman. Of course, kinsa may motor sa mga charges kung walay battery, walay source of voltage. Next, closed loop wiring. The closed loop of wiring serves as a conducting path for the electric charges to pass through. Meaning to say, dapat ang imuhang wire na ay closed loop. Lagi na ni, na ay closed loop. Close, mubalik. Kung imuhang wire gani, yun ana, bisan pag pilay, voltahe ana class. Bisan pag 1 million ang voltahe ana niya. Okay? Na kay suga dire. Ana, nya gabot nimo dire putol. Nya dire putol. Bisan pag unsa kadako sa voltahe diha, ngano man kay walay kuryente, dili mudagan ang imong kuryente. Nganon di mudagan imong kuryente? Bisan pag itod ang mayo ang mga charges, igabot dire asa man siya molupad. Magmangambak siya padung dito. Dili. So dili gyud na wa na di gyud nimo siga imong suga ani because there is no closed loop. Next, electrical load. Electrical load is needed so as to prevent short circuit. Nabutangan po nimo og electrical load, dili po pwede nga mag-ana ra po ka. Battery ana. Dito ra nimo connect. Dito nimo connect ana, sa may tabo. Short circuit because there is no resistance, zero resistance man. And zero resistance, tanang kuryente mo mag-abot sila, imong battery manginit. Iginit sa imong battery, there is a chance nga mo buto. Okay? Sunod. Means of opening and closing of circuit. So, usually, nagita ibutang nga switch para makontrol na to ang pag-on o off sa atong circuit. Okay? So, natay Ohm's law. Ohm's law, it states that the current flowing in a circuit is directly proportional to the voltage and inversely proportional to the resistance. Ano yung mga formula for Ohm's law. But so that we can understand completely, yan ay dali kayo nga mahinumduman na to ang Ohm's law, na ako i-show ninyo nga video.
Hey there guys, Paul here from the engineeringmindset.com. In this video, we're going to be looking at Ohm's law to understand how it works as well as how to use it. There are also two problems at the end of this video for you to test your knowledge and see if you can solve. So what is Ohm's law? Ohm's law is the relationship between voltage, current, and resistance and how they relate to each other. Ohm's law was developed by a German physicist named George Ohm, who undertook many experiments to develop his theory, including measuring current by touching live electrical circuits to see how much it hurt. As you might imagine, the higher the current, the more it hurt. Now, there are three formulas we need to use for Ohm's law, but we don't actually need to remember these, and I'll show you a super easy tip in just a moment. So the three formulas we use for Ohm's law are voltage equals current multiplied by resistance, current equals voltage divided by resistance, and resistance equals voltage divided by current. If that seems like a lot to remember, then don't worry, because we don't need to remember them. All we need to remember is Ohm's triangle, which looks like this. So you just need to remember these three letters in order, V, I, R. Then we just write those letters in a triangle with V at the top, and we draw a line to separate the letters. In fact, you don't even need to remember those because I've made a free PDF guide for you with some worked examples which you can keep on your PC or your mobile and access wherever you need. Links for that can be found in the video description down below. Now, all we do when we need to use a formula is cover up the letter we need. So if we want to find the voltage, then we write V equals and then pop the V in a triangle. That leaves us with I and R. So we write I multiplied by R, which means voltage equals current multiplied by resistance. You can write a little multiplication symbol in the triangle between the two letters if it helps you. Now I know what you're thinking, why is current represented with the letter I and not a C for current, or even the letter A for the unit of ampere? Well, the unit of current is the ampere, or the amp, and this is named after André Ampère, a French physicist. A couple of hundred years ago, he undertook lots of experiments, many involved varying the amount of electrical current. So he called this intensity du current, or the intensity of current. So when he published his work, they took the letter I and it became standard until this day. Now you might also come across formulas where the letter E is used instead of V. The letter E stands for EMF, or electromotive force, but don't worry about that. Just stick to using V and substitute V for E if you see it used in Ohm's law questions. Anyway, so by covering V, we get voltage equals current multiplied by resistance. If we want to find current, then we write down I equals, and then we cover up the letter I in a triangle. That gives us V and R. So as V is above the R like a fraction, we can write V divided by R. Therefore, current is equal to voltage divided by resistance. If we want to find resistance, then we write down R equals, and then we cover up R in the triangle. That leaves us with V and I. So we write V divided by I, which gives us resistance equals voltage divided by current. Let's look at some examples for how to use these formulas. First, let's see how we find voltage and how it relates to the other parts. Let's say we have a simple electrical circuit with a battery and a resistor. We don't know what the voltage of the battery is though. The resistor is 3 ohms, and when we connect a multimeter into the circuit, we see that we get a reading of 2 amps of current. We want to find the voltage, so using Ohm's triangle, we can cover up the V, and that gives us V equals I multiplied by R. We know the current is 2 amps, so we can write that in, and we know the resistance is 3 ohms, so we can write that in also. Therefore, 2 amps multiplied by 3 ohms gives us 6 volts. The battery is therefore 6 volts. Now, if you want to check your answers for Ohm's questions, then I've built a free calculator on the website. You can just drop your numbers in and it will do the calculation for you. Links for that again in the video description down below. Coming back to the circuit, if we now double the voltage by connecting 2 6-volt batteries in series, we get 12 volts. If we now connect this to the same circuit, the current also doubles from 2 amps to 4 amps. If we double the voltage again to 24 volts, the current will also double to 8 amps. So what's the relationship here? We can see that current is therefore directly proportional to voltage. If we double the voltage, we double the current. Remember, voltage is like pressure, is the pushing force in the circuit. It pushes the electrons around the wires, and we place things like lamps in the way of these electrons so that they have to flow through these, and that causes the lamp to light up. By doubling the voltage, we see that the current also doubles, meaning that more electrons are flowing, and this occurs as we apply more pressure or more voltage. This is just like if we were to use a bigger water pump, then more water will flow. Okay, so what about finding current? Let's say we now have a 3 ohm lamp connected to a 6 volt power supply. To find the current, we write down I equals, and then we cover up I in the triangle. That gives us V divided by R, so current equals voltage divided by resistance. We know the voltage is 6 volts and the resistance is 3 ohms, so the current is therefore 2 amps, and that's what we see on the multimeter. By the way, if you don't have a multimeter, then I highly recommend you get one. It's essential for troubleshooting, but also building your essential electrical knowledge. I'll leave some links down below for which one to get and from where. So we saw what happens when we use a resistance of 3 ohms in the circuit. But if we double the resistance to 6 ohms by placing another 3 ohm lamp into the circuit, the current halves to just 1 amp. If we double the resistance again to 12 ohms, the current will halve again to 0.5 amps. We can visually see this because the lamps will become less bright as the current reduces from the increase in resistance. So what's the relationship here? We can see that the current is inversely proportional to the resistance. When we double the resistance, the current will decrease by half. If we halve the resistance, the current will double. Current is the flow of electrons, or the flow of free electrons. For us to make this lamp shine, we need to push electrons through it. How do we do that? We apply a voltage across the two ends. The voltage will push the electrons. The atoms inside the copper wire have free electrons in the valence shell, which means they can very easily move to other copper atoms. They will naturally move to other atoms by themselves, but this will be in random directions, which is of no use to us. For the lamp to turn on, we need lots of electrons to flow in the same direction. When we connect a voltage source, we use the pressure of the battery to push the electrons through the circuit all in the same direction. For example, to power this 1.5 ohm resistive lamp with a 1.5 volt battery requires 1 amp of current. This is equal to 6,242 quadrillion electrons passing from the battery and through the lamp every second. And if we can achieve this, then the lamp will stay at full brightness. If the voltage or current reduces or the resistance of the circuit increases, then the lamp will become dimmer. Okay, now let's look at finding resistance. Say we have a resistive lamp connected to a 12 volt power supply. We don't know how much resistance is adding to the circuit, but we measure the current as 0.5 amps. To find the resistance, we write down R equals, and then we cover up the R in the triangle. We're left with V and I, so resistance equals voltage divided by current. We know the voltage is 12 volts and the current is 0.5 amps, so 12 divided by 0.5 gives us 24 ohms of resistance. Resistance is the opposition to the flow of electrons. It tries to prevent electrons from flowing. That's why we use resistors in circuits to reduce the current and protect components such as an LED. If we try to connect an LED directly to a 9 volt battery, it will blow out because the voltage and the current are too high. But when we add a resistor into the circuit, then these are reduced, so the LED is protected and will shine brightly. So given the circuit, we can increase the current by increasing the voltage, or we can also increase the current by reducing the resistance. We can also reduce the current by increasing the resistance. Okay, time for you to test your skills. Can you solve these problems? I'll leave a link for the answer and the solution in the video description down below.
Okay? So, basically, di ba, nakita yun dito sa yung animation, nakita dito nga, ang copper wire na ay valence electron, which is freely moving. Nga mo ito gikinahanglan nga atong ipangtulod ang iyang mga electron. Kung saan pagtulod, mo ito gamitan na ito og voltage source. Okay, so basically, sa Ohm's law, mao ni siya ang atong bantayanan, mga formulas. the current kuno is directly proportional to the voltage and inversely proportional to the resistance. Mo gini siya original sa Ohm's law. Then ato lang na siyang gi-manipulate using algebra mo na nakakuha tag lain-lain nga klase. Are there any questions so far?
Not so far, sir.
Okay. So muna na siya, no? Limitations of Ohm's law. For metals which get heated up due to flow of current through them. Okay? So nga naman, because as the metal or as for metals which get heated up due to flow of current through them. So kung sa may mahitabo. Okay. We already know nga ang resistance is mo siya mupugong sa kuryente aron dili mo freely flow, di ba? Mo mupugong ang resistor. Now karon, siyempre kay mupugong man siya, kung mo na imong metal, gagian na siya kuryente dire, gagian kuryente, iyang pugngan diha. So, what will happen is that nagi tendency nga kani siya is musaka ang iyang temperature. Ano man, gasigi ko kag pugong. Gisigi ko pugong sa mga electrons yan, nag-flow ang electron per minimo. So, siya buhaton. Once musaka ang temperature sa metal class, niya, significant ang iyang pagsaka, ang may tabuan na niya mutaas iyang resistance. Yan naman. Di ba? Ako nang i-discuss, what is the effect of temperature to the molecules and the atoms. Once there is an increase in temperature, what will happen is that the molecules or the atoms in your material will get excited and they will go far away from each other. Okay, for example, samtang dili pa init, ang copper molecules, gingunaan nila, yan na siya dire free electron, na siya free electron. Dool ra kayo, dali ra kayo ang pag-transfer unta from one atom to the other. But kung giinit na siya nimo, there is a chance nga ang mga atom nimo is mulagyo. Now, kung lagyo na siya, what will happen? The resistance, lisod na kayo ang pag-move, nga naman, kinahanglan kag dako-dako nga force. Now, kay lisod ba na pag-move niya, what pasabot is that kinahanglan kag dako nga force. Now, kung kinahanglan kag dako nga force, dako nga voltahe, what pasabot na niya day ning taas ang iyang resistance. So that is why Ohm's law is limited only kung na-change temperature but dili kayo dako. But kung dako kayo ang change sa temperature, na for metals which get heated up due to flow of current through them, Ohm's law can never be applied anymore. Usab naman ay resistance. Napa, for electrolytes where enormous gases are produced on either electrode. Okay? When we say electrolytes class, it is a liquid that sometimes supports a generous flow of electricity. Now, kung sa may nahitabo, kung ni-produce kag enormous gas, ang nahitabo di ay is that the energy, the electrical energy is not being transferred. Wa niya ma-move dito tanan. Yun sa niya, iyang gigamit ang electrical energy in order to convert the electrolytes into a sort of a gas. So, because we all know that energy cannot be created nor destroyed. It can only be transformed from one form to another. Now, kung diha lang dapita, wala magamit ang tanan nga energy, flow of electron, electrical energy, wa magamit, wa niya mapasa dito sa tanan because iyang gigamit in order to convert some of the electrolytes into gas, then therefore dili siya efficient. So dili applicable ang Ohm's law. Then for vacuum radio waves, of course vacuum man, so meaning to say wa siya material, wa metal. For arc lamps, for semiconductors, for gases filled tubes in which the ions are generated as a result of current flow, for appliances such as metal rectifiers and crystal detectors in which the operation depends on the direction of current. Dili pwede gamiton ng Ohm's law na. Now let us proceed to resistance. The amount of current that flows through the wire depends on the metal from which it is made. It is the opposition or friction to the flow of current, no? Sa ganiha, sa video presentation, sa animation niya, gipakita dito nga ang iyang resistance is katong kuan, mura siya o gipugngan niya ang tubig nga aron dili mo, di ba? Iya man tong gigamitan og analogy. Iyang gipakita nga ang voltage source is the water pump, then ang wire is katong mga tubo, then kung unsa ka kusog imong pump, mo sa kakusog ang flow sa wire, but there must be a resistance nga mo'y magpugong aron ang imuhang magpugong sa imong kurente, or else mahimo man siyang short circuit. The resistance of a piece of wire depends on its length and its cross-sectional area or thickness, and the longer the wire is, the greater its resistance. The thicker the wire, however, has less resistance because a thick wire offers more room for electric current to pass through than thin wire does. Okay? Mo siya example ani. The image of the right shows the effect of length and surface area of the resistance of the conductor. Now, assuming nga dakay duha ka wire kaning sa ibabaw nga picture. Assuming nga nakay duha ka wire. Tara atong padakan gamay. Assuming nga nakay duha ka wire kani. They have the different lengths. Ang usa na length 1, ang usa na length 2. Take note, kani siyang mga gray diri, mao ni siya ang mga atoms. Okay. So, unsa may mahitabo? Kung taas imong wire, daghan kay ambakan ang mga electrons, di ba? Usa siya moabot diri. So kay daghan man siya, daghan siya, lisod kay siya igtulod. Una-una agad kanang sa atong hatag example mo ana ka sa Gaisano, di ba nay tulod-tulod diha pushcart sa Gaisano, no, ipanglumpong na daghana o daghan kaayo mga 20 ka pushcart, isuway og tuod. Di ba bugat kayo itod, gahi kay itod. Ano man, taas kay kagitudan, bugat kayo, dako kay siya mas. Now, testing gamita duha lang ka buok ilumpong, di ba dali ra kay itod. Ngano man, siyempre kay gamay raman siya imong itod. So what I'm trying to say is that kung kanira siya mubo ra nga wire, nya maura ni ihang molecules or atoms, dali ra kay ang pag-transfer sa electron, mubo ra man kay siya transferan. Dinhe, lisod-lisod siya transferan. Ngano man, taas man kayo, daghan man kayo siya, daghan kay kag electrons nga ibton. Okay? So, what I'm trying to say is that the length of the wire matters. The longer the wire, the greater is the resistance. Now, karon, as the surface area of the conductor increases, the lesser is the resistance. Since bigger surface area provides more pathway for current to pass through. So, in this case here, parehas la katasa, but ang usa ka wire is dako, ang usa ka wire is niwang. What will happen? What do you think would happen? Nasa surface area 1, kani usa surface area 2. Mas minus og resistance kani siya. Nga naman, daghan magkagian, daghan siyang choices, daghang path nga kagian ang kurente. Dili, taas siyang resistance kay gamay ra. Gamay ra siya kagianan. This is the main reason nga no sa atong balay, ang atong service entrance nga wire, dagko gina siya. Kanang wire nga gikan sa poste as compared sa wire nga gigamit nato sa atong sulod sa atong balay. In fact, gagmay ra kay ang wire nga gigamit nato sa suga. But dagko kay ang wire nga gamiton kung gamit ang mga welding machines. Ano man? Tungod ana. Kinahanglan magdako nga power. Now kung kani imong gamiton, ya gagamit ka welding machine, ya gamay nga wire mong gamiton, what do you think would happen? Kinahanglan mo siyang taas nga current. So sa buhaton, paspasan og tuod. Paspas kay ang mga gis imong wire. Kay paspas kay ang mga gis imong wire, what will happen is muinit ang imong wire. Unya masunog. Okay? So, mo na yung formula for resistance. Resistance of a conductor can be determined by the type of material it is made. Resistivity, P, constant siya, kung lain nga material, say for example, aluminum, lain na siya resistivity constant. Imong wire is copper, lain siya na siya resistivity constant. Then L is the length of the wire, and A is the surface area. Sometimes, gagamit og metric system, mo tong gagamit og ohm sermel dire meter dire is areas, which is meter squared. Area of a circular conductor is just the square of its diameter in mils, making its unit into circular mils or cm. Unit for the length is in feet. Resistivity is a constant depending on the type of material used. And unit for resistance is in ohms. Okay? Mo na yung mga unit. Unit for R is ohms. Mo ni. Resistivity of the conductor, ang unit niya is ohms per mil per feet. The length is in feet and the surface area is in circular mils. Now, mo ni siya ang mga resistivity for common conductors. Now, if you're using silver, mo ni ihang resistivity constant, 9.8 circular mils per foot. And if you're using copper, we have 10.37 circular mils per foot. Gold, 14.7. Aluminum, 17.02. So makita na to dire nga the best conductor gyuday is ang silver. Mo may pinakagamay. And we all know na kung gamay na siya, siyempre gamay o resistance. The best conductor, elemental semiconductor is the silver. Okay? So, nani dire, mugawas na sa itong exam ha. You need to be familiarized with this. Ako ra bang nakita no nga ang atong link sa recording, akong i-upload man to sa YouTube, niya akong gibutang sa atong Google Classroom. Kamay ra ang nananaw. No? So, mo ni akong kuan karon, dili na ko mo-upload aning PowerPoint sa atong Google Classroom. Ang akong i-upload is the link of our recording so that katong mga wala ka paminaw, at least makadungog sila sa akong tingog. Okay? Any questions so far? Pangutan na. O maghatag tayong example.
Sir.
Question. Insipido. Insipido, question.
Wala ko question.
Sir, nakita ko sa akong libro kay maghatag tayong example. Ay na lang. Maghatag ko ang example, i-upload na ko sa atong Google Classroom. Please, every now and then, please check your Google Classroom, ha? Maghatag ko example ano niya, Ohm's Law, o kani, before ta mag-exam. We will have our exam next week, probably Monday. Ugma, Friday man ugma, no? Relax at ugma. Kay aron makahatag og example. Kay wa pa mo ko kahatag og example karon. Okay? Nay pangutanan, naglibog ninyo?
Nawara, sir.
Okay, let us check your attendance.
Excuse, sir.
So karon is 14. Adolfo. Wa. Ampuon. Wa. Arubo.
Present, sir.
Okay. Barbecho.
I'm here, sir.
Binimerito.
Wala na siya sa
Wala na eh. Buok. Okay, nas buok. Bukog, Cristel. Namas Cristel, pero wa siguro ni maminaw. O mo tingog. Busmion, Hazelan.
present,
Busmion,
sir.
Calaurian, Rizal. Okay na.
Present.
Campo Redondo. Campo Redondo na.
Present, sir.
Cardama.
Present, sir.
Del Mundo, Sherwin. Undang na rin, no?
Present, sir.
Di mo ka Del Mundo kon si Ampuon mo ka. Ay, ikaw ra ni daw.
Oo, sir.
Kaduham ka na lista lagi dire. Unsa may tinuod apelyido nimo dong? Ampuon, Del Mundo.
Ang poon, sir. Middle initial, Del Mundo.
De La Cruz, Jorkia Clairol.
Present, sir.
Dupalag, Michael.
Present, sir.
Erasmo, Jessa Lorraine.
Present, sir.
Fuentes, Cheryl May.
Present, sir.
Gabales, Joan.
Present, sir.
Unsa may apelyido nimo day? Abarico o Gabales?
Abarico, sir.
Ano man yung Gabales man yung muha lagi dire?
Middle initial na ka na, sir. Gabales, Abarico, kung kuan.
Okay. Gonzaga Grace,
Present, sir.
Greenhia Glendo. Wala.
Present, sir.
Ano? Insipido Charles.
Present, sir.
Iroho Juvilin.
Present, sir.
Landiza Marjorie.
Present, sir.
Lapos Gisrel.
Present, sir.
Libradilla Mark Jason.
Present, sir.
Kanay mo po dong. Unsa may apelyido nimo dong?
Ugabang, sir.
Gabang.
Sir.
Liego Daname.
Present, sir.
Maglangit Estelito.
Present, sir. Present, sir.
Malalay Mirian.
Present, sir.
Malaza Mark Greenhia. Agrege. Malaza. Wala. Wala. Manolo, Chester.
Present, sir.
Marabiles, Margian. Marabiles, naa siya pero wa mo tingog, wa maminaw. Memorasyon, Mark Joseph. Memorasyon, wa. Oliveros, Arman.
Present, sir.
Oliveros, Arman.
Hala, tangin.
Wala.
Sir, present.
No present. Untales, Alice Jane.
Present, sir.
Punsika, Ninyo Jade. Punsika, wa. Rapuela, John Jason.
Present, sir.
Okay. Ricawerta, Rodilen.
Present, sir.
Sabanal, Giselle K.
Present, sir.
Sagayno, Kent.
Present, sir.
Salatan, Joy May.
Present, sir.
Samyon, Michael B. Samyon, wa. Umarsi, wa. Okay, kindly
Sir.
open
Present, Adolfo, sir.
Adolfo. Di mo ganiha day.
Wala, tingog akong kuan, sir.
Namang. Please, kuan, please open your cam. Kadali lang, bahala ngit-ngit.
Hoy! 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 Tama. Tama.
Open your cam, nila, sir.
Hit man, sir.
Sige lang, kanang ngit-ngit. Sige na lang. Basta lang na open ang cam.
Ambat luyo, sir.
Sige, open your cam ha. Ipakita ang smile sa bao. 1, 2, 3, smile. Good sa ha. Atong tanawon sa og na-save ba. Ayun sa ha. Saglit lang, gamay. Okay. Say, brother. Sige, salamat. Thank you for listening. Yan. Ugma, dili na ko mo klase ninyo, ugma. But I will be posting sample problems in our Google Classroom. Kindly read, ha. Yan, ang recording sa dani, ako sang i-post dito sa Google Classroom. Please read, kaya dili na ako ipada ang PowerPoint.
Excuse me, sir.
Oh, ano saman?
Pero mangayog code sa kuan, sir, kanang Google Classroom, sir.
Ano, wa pa kay code, eh?
Wala, sir. Wala pa ako kasod ato, sir.
Sige, ang code kay B4AQBDK. Ako ibutang sa chat box, ha? Sige, sunod yun mo sa Google Classroom kay ang atong sunod nga exam dili na ko i-post sa atong group chat.
Sir, thank you, sir.
Ya, kinahanglan i-submit ninyo, ha. Ang sunod nga exam ba i-submit. Iguman yung answer sa Google Class, kanang igsuon nyo sa Google Classroom at class activity, mo answer mo dito sa Google Form. Kung mag-answer ninyo, inig-save na, i-submit pag yun ninyo so that ma-record sa Google Classroom ang inyong scores.
Okay, sir.
Okay, sir.
Okay, sir.
Yes, sir.
Okay, sir.
Wala na ipangutana?
Wala na tawon, sir.